seat and take place so that we can begin. I think we should be on time. We are slightly, few minutes late, and therefore I invite you to sit down and okay. I may begin. Don't be afraid. I will not be long. You are waiting for Arthur and not for Philippe Trainard, and I am sure you are absolutely right. I would like to, just please, a few minutes. I would like to insist on the fact that there is a clear and increasing interest currently in the ethical and societal implications of machine learning and artificial intelligence. And you are all concerned by these developments. The goal of the SCOR Foundation workshop on confidence and fairness and the scientific foundation in artificial intelligence and risk is to discuss 5 main topics. The first one is algorithmic fairness and bias mitigation. The second one is the ethics of artificial intelligence and machine learning. The third one is transparency and accountability in artificial intelligence systems. The fourth one is regulatory and policy implication of artificial intelligence. And the last one is, of course, the biggest one. You may think it's human rights and artificial intelligence. I have the pleasure to introduce Arthur Charpentier, who is professor at the University of Quebec in Montreal, Canada. And I will not develop what he's doing, what his work, because I know you probably know as well as myself his work, maybe better than myself. And therefore, I want to be short, and because there is no need to present him, as we have all read his papers and contribution. Not probably all, because you are very efficient from an economic point of view, theoretically and practically. Let me add that he is leading a very important 2023-2026 project of the SCOR Foundation for Science on fairness and of predictive models and application to insurance markets. This project, of which this workshop is part, is supported by the SCOR Foundation for Science. It addresses, of course, bias within the automatic artificial intelligence algorithm utilized and used to determine the optimal pricing in individual policies. Arthur, I would like to thank you very much for having organized this very attractive workshop. You have now the floor, and of course, I let you present the prestigious speakers. You will be listening and you will be questioning. Thank you so much, Arthur.
Thank you, Philippe. So good morning everyone. I'm glad the room is full. I'm very impressed. So we have a workshop on confidence and fairness on scientific foundations in AI and risks. So indeed, it's related to a project I'm running in Montreal with a lot of students and postdocs and colleagues, funded by the SCOR Fondation for Science. So we have this workshop today with a lot of esteemed colleagues who've been working on this area for some of them for a long time. And I wanted to get everyone in the same room to discuss and get different perspective on very close topics related to these questions of fairness, discrimination, causality, and confidence, right? So there was nothing about insurance in the title. Actually, it is in the title of my grant, which is about fairness in predictive markets with application in insurance. I'm going to talk a little bit about insurance because obviously a lot of things that we're going to discuss about today can be extended outside of insurance markets. But interestingly, in insurance, there are a lot of problems somehow specific to insurance, or at least perhaps a little bit more complicated than what you can see outside of insurance. So I will try to explain why insurance is somehow specific when you talk about confidence, about predictions, about fairness, about discrimination. And I'm going to explain what we've been doing so far. So far we had only 18 months. We still have 18 months to run. But we have already a lot of work, a lot of papers, a lot of one book. And so I have a big team in Montreal. So some of them are funded by the foundation. Some are colleagues. Only one is in the room. It's Olivier, coming from Quebec. So he's a PhD student. Everyone else is still sleeping in Montreal right now. And I was asked François. Sorry, François. Yeah, but François left. So now he's back in Paris. So he's no longer a student. Actually, he's working. Well, students are working too. So insurance. So just to get back on the basic of insurance, I'm very sorry for half of the room who knows that, but I think it's important to go back to the basics because there's a saying that I like, which is insurance is the contribution of the many to the misfortune of the few, which is, I think, a nice definition of what insurance is. So it's really about having a lot of people, they have some risk and they want to get rid of that risk somehow, and they're going to pay an insurance premium to an insurance company, and if they got a claim, then they're going to get some money back, right? So we have this idea of pulling risk together. So it's a very old way of dealing with risk, and in the 60s, Kenneth Arrow introduced a concept which is somehow related to what we're talking about, which is the idea of actuarial fairness, right? So there was this idea of fairness in insurance a long time ago, but when you go back to the paper of Kenneth Arrow, it was about health insurance. What he says basically is you have actuarially fair premium if you use the expected value of the losses as a premium. So the contribution we're talking about, the amount you're going to transfer to the insurance company to get your losses paid back if you got a claim, should be related to this expected value. So this is called fairness, but we don't see why it could be fair. Actually, if you want to understand why it's fair, we have to split it in different ways. So first, I should also mention something, which is the fact that in insurance, so it's not like efficient financial markets, we don't have the law of one price. So it's not one risk should have a price or a value. Actually, if you got two insurance companies, they can get different prices because they got different models, because they got different data sets, and it's okay. Okay, so insurance markets are complicated because it can be seen as a competition of predictive markets, predictive models. Okay, the other thing is the fact that basically insurance, if you take it from a legal perspective, is the risk transfer. So it's the idea of having a contract. So someone is going to buy a contract, an insurance contract, paying a premium, and if you got a loss, you're going to get an indemnity from the insurance company. And this is where we have this fairness. So fairness has nothing to do with any ethical problem, with any legal problem. It's just, actually it's related to what the word Philip was using before. It's about efficiency. It's related to the fact that in this one-to-one contract, if you charge more, then it's unfair because actually the insurance company will make some money. If you charge less, then the policyholder should somehow make some money, or at least the insurance company will probably lose money. So it's a balance we have between policyholders and insurance company, but it has nothing to do with fairness. It's just about the efficiency of this one-to-one relationship. But insurance is more. Insurance is about creating a pool of people contributing to transfer their risks. And I think this is where we have this question of fairness and discrimination and those kind of problems, because we want to find a way to get a fair contribution of people. So people are willing to pay something. Perhaps they have different risks. So we want the premium to reflect the risk of individual people in a good way. So we're going to talk about that. So this question of what we usually call fairness is related to this question of how should we divide the cake. Okay. So this is about this kind of question. How do we split the loss? How do we split the premium among policyholders? Okay. So it's both at the same time. It's a transfer, but it's also a risk sharing. Okay, so I can mention a couple of papers. So actually, a lot of people in the room have been working on those topics, so I can only mention some of them. But Michael has been working on this question of trust and confidence. And indeed, because we have this transfer, there is a question of trust. Insurance is really about trust. It's really about giving the money to an insurance company and hoping that in the case you got a problem, they will pay you back. So it's really about confidence and trust. Okay, so we need this for insurance. But it's also about risk sharing. It's really about cutting the cake. What is fair? how can we fairly split the cake? Because if I assume that I got a huge portfolio, then basically I know how much it will cost me. And then we have to split it to get the premium. Because basically, if you get back to the definition, you collect the premium and this should be sufficient to pay for the losses. Okay, so it's really about cake cutting. If I used to, Toon wrote a paper on this idea of cake cutting, I keep this expression, but it's really about how can we fairly divide the cake of the expected losses among policyholders to have fair contributions. And we need trust. So I did mention a confidence in the title because this is something extremely important in insurance. If policyholders don't trust the system, then we have a problem collectively, right? So trust is something extremely important, and we've been working recently on those questions. So we wrote a series of papers. I just mentioned the work we've done over the past years, but I'm not going to go into details on those. So I'm going to talk about discrimination. So discrimination, so I will not get too deeply into the definition. I take a sentence from the dictionary, actually. So it's not the first definition you can find in the English dictionary, but I like this one because it says that discrimination is the act, practice, or instance of separating and or distinguishing categorically rather than individually. Okay, so it's really the idea of creating groups of people and treat them as part of the group and not as individuals. So this is discrimination if you look at the dictionary. And interestingly, this is exactly what actuaries are doing. Okay, the job of actuaries, and this is coming from a very nice book in philosophy by Friedrich Schauer on probabilities and stereotypes, saying that basically actuaries look at people not as individuals but as members of categories. And it has been stated by actuaries for already almost 100 years. The fact that actuaries create groups of homogeneous risks and they use that as an information to set the premium. Okay, so seeing people as member of group is a very old practice in insurance, which makes a lot of sense for many reasons. We see more and more people focusing on personalization of insurance premiums. So we want to treat people individually. People like that. They want to be treated as they are and not members of groups, but it raises a lot of questions, actually. So there's some questions, we started to focus on them in this past month, but it's a very important problem of how do you deal with personalization in the context of insurance. Everything is in this context of AI, so we did also, I think, put AI in the title, but it's really about data and models. So data and models raise a lot of issues because big data means that you can collect more and more information about people, and very easily you can make proxy discrimination. Because even if you're not supposed to use something, well, possibly if you get more and more information about someone, well, there will be proxy discrimination. It was mentioned in this nice book by Cathy O'Neill on weapons of mass destruction, saying that basically if we don't use the race, well, if you use a zip code, especially in the US, you're going to focus on something which is very close to the race. And actually this idea that race can be captured by zip code has been mentioned in the insurance legal framework because in Colorado, in the US, for instance, insurance companies ask insurance companies to prove that they were not discriminated with respect to the race, right, which makes sense from a social perspective. But then insurance companies said, well, we don't collect the race. So how do you want us to do something? And then they say, you're going to predict the race because you can get the zip code, you can get the last name and first name. So basically, you should be able to make a prediction, right? So it raised a lot of interesting questions. So we have this issue of having a lot of data that can be used as proxies. So how do we deal with that? Because, well, we still have this problem of indirect discrimination. Okay, so using proxies can be seen as discriminatory from a legal perspective, but it's basically what actuaries were using, what we are doing. When actuaries have been using the gender in motor insurance, it was just because they got that in the data, and they did observe that men and women were different. Okay, so it's really what we can observe, and there's a big problem also with machine learning, which is the fact that machine learning is basically about generalization. So it's basically the fact that you have a training data, and you want to create a model that is going to minimize the loss, and you expect that it's going to work on a different data set, which will be actually the portfolio you might get next year. But generalization means basically that the model is supposed to replicate what you got in the data. So if you got a difference between men and women in your data set, so this is motor insurance, we got a difference in claim survival for men and women, right? Whatever you do with your model, even if you never use the gender, even if it's very difficult to predict the gender, okay, so it's not about predicting a sensitive attribute. It's just the fact that if you got a difference between groups, basically, if you put more and more variables, you're going to replicate what you observe in the data. Okay, so removing a variable is obviously not the solution because, well, the model is designed to generalize. So if you got something in your data, the model will do everything it can to replicate what you observe. So if you got a difference based on the gender, even if you don't put the gender as a variable, then somehow it's going to use other attributes, and you're going to end up with the same discrimination as before. Okay, so it's a problem, an important problem. Still difficult to discuss from a mathematical perspective, I think, but at least we can discuss from a philosophical and having an economic perspective on those questions. So we've been also working on different things and try to make actuaries at least aware on those about those problems, about those issues. So it's important to know that it's not that simple, and we need to think more about those issues. Right. Another issue is about interpretability, because if you want confidence, I think it should be related to questions on interpretability, about transparency. And interestingly, a lot of concepts you can get from machine learning are not exactly what actuaries should be using. There's a lot of papers about, for instance, accuracy. People want very accurate model, but it's not exactly what actuaries are looking for. One of the reasons is basically if you look at most of the literature on fairness and discrimination in computer science, people are focusing on categories. You want to predict a category. Okay, so you want to know exactly if you got a cat or a dog on a picture, if you have a dog or a wolf. Okay, so that was this well-known paper by Rivero on this interpretability problem. But it's not what we look for in insurance. I don't want to know who's going to get a claim. What we want is, if we get back to the basics, is we want to find a fair premium, a fair contribution of people. So what we need is not a prediction of who's going to die or who's going to get a claim. It's really about the probabilities. We want to get a good assessment of the probabilities to claim a loss, because the probabilities will be reflected in the premium. Okay, so it's really about focusing on probabilities, which is not exactly what you got with accuracy. I think accuracy is something else. What we should care about is more calibration. So calibration is something extremely important and obviously underrated in the literature. It's also related to this question I was raising before about this problem of personalization, which was already raised in textbooks in philosophy, especially philosophy of probabilities. The fact that when you think classically about probabilities, you think of frequencies. Okay, so it's about repetitions of events. Okay, so you're going to say that 12% makes sense because if you repeat the experiment a lot of times, you're going to be very close to 12%. But in insurance and in many applications, it's usually a one-shot problem. Okay, so it's only something. If I tell you that someone is going to die with 2% chance of dying, at the end of the year, whatever the outcome will be, there's no way to know if this 2% makes sense. Okay, whatever the outcome. So defining analyzing the outcome of a model is difficult. It was already very difficult to assess if a probability somehow makes sense, but if it's coming out from a machine learning model, we need more than focusing on accuracy, actually. So I can show you some work we've done about calibration. Okay, so still I'm working on this idea of focusing on claims frequency in insurance. Okay, so we've been using classical econometric models. Actuaries have been trained using econometric models, which have deep roots connected with probabilities. And then they've been using machine learning, like boosting, random forest, neural network, or whatever. But we want some properties in insurance. Like we want the global balance. So global balance means basically the expected value of your the outcome of the predictions should be equal to the expected value of the losses, meaning basically that the average value of what you collect should be equal to the average value of what you're going to pay, which is a very natural property that you want from the definition I gave you about insurance. It's really about pulling together people. We collect the money, so we're going to sum all the predictions, and we want the sum of the predictions to be equal to the sum of the losses. So this kind of properties is actually very natural in sample when you focus on GLM. So if you're in a logistic regression, you have this property. Okay, so it's just the first order condition you get from GLMs. But it's something that unfortunately you might not have in some cases when you use machine learning. But this global balance might not be sufficient. Maybe you want something like a local balance. Maybe you want to get this average value to be the same in some segments of the population. And maybe you want it if you focus on the conditional on the prediction. Meaning basically if I take all the people that are going to cost me, according to my model, like 100 euros, well, I want that all the people that got a premium of 100 euros actually cost me individually 100 euros. It makes sense in the context of competition, actually. Okay, so focusing on this property, which is exactly the definition of calibration, makes a lot of sense in insurance. And if you look at, maybe I can go to the second one, when you look at those calibration curves mean I'm going to look at my prediction and see if I focus on people who got predicted like 10% chance to claim a loss. Are we close to the 10%? Well, if we're not on the diagonal, we got a problem. It's not well calibrated. And what we can see is usually econometric models are much better calibrated than machine learning models. Or at least we can find some sort of guarantees, right? So it's something extremely important. And what we've been working on last year, especially with Agathe, who studied a PhD, is, well, calibration is nice, but maybe it's not sufficient. There's something else we want. Maybe we want something on the distribution of the predictions. Why? Because it reflects somehow the belief you have about the probability of claiming a loss in insurance. Do we really believe that some people got 0.00%, 1% chance to claim a loss? Do we really want to get people in the portfolio with a premium of €1? Or do we believe that actually the distribution is more like almost everyone is between 3% and 25%? What should be the range of the underlying probability? It's very difficult because we don't observe this. Okay, so it's the underlying probability of claiming a loss in whatever risk you might be thinking of. And there's no guarantee actually to get something that makes sense. And it's very easy to get a well-calibrated model, but with very stupid distribution of premiums, actually. So we need something more than calibration. So it's some kind of work we've been working on. So this is ongoing work, and we're still focusing a lot on those questions because they make a lot of sense in machine learning, especially focusing on insurance problems. Now, fairness. So fairness is complicated for many reasons. I did stole I think it's the very first paragraph of a chapter in the Handbook on Discrimination. So the Handbook on Discrimination is a very nice book with a lot of topics written by different people. And one of them is only about insurance. So, and what it says basically is insurance is complicated because even if you do statistical discrimination in insurance, proxy discrimination, there's no malicious intent of actuaries most of the time, okay? And it's just because, well, that's what you got in the data. Because when you collect information, especially 60, 70 years ago, what you collect is what you got from the forms people have been filling. So you use this information, which is basically the idea of gender. We got the gender from the policyholders because that's the very first question you ask. Should we ask you Mr. or Mrs. just for civility, right? So you got somehow an information about the gender of people, and it looks like it's a significant variable in a statistical perspective. But does it make sense? So we start to have questions about causality, about interpretability again on those models. And in this article, he says something that I really like, which is that at the core of insurance business lies discrimination. Actuaries are paid to make discrimination in the sense I showed you before in the dictionary about segmentation, but actually it's discrimination based on the risks. Actuaries should ask a higher premium for more risky people, but it can be seen as a non-legitimate discrimination because actually all those legitimate attributes might be correlated with sensitive attributes. And this is a big problem, actually. And it's very difficult to understand, especially if you just focus on correlation, where is discrimination coming from? Is this coming from a legitimate variable, or is it coming from a protected attribute, actually? Okay. And the second point is coming from a textbook of Kernth and Roth on discrimination, algorithmic discrimination, saying that basically machine learning will not give you anything like gender neutrality, which is more or less what you got in insurance regulation in Europe, for free. Okay, you must ask for it. So I like that because what it says is we must explicitly say what discrimination is. I mean, we can put a lot of words, but at the end we need to get formulas. We need to define properly what discriminatory means and put that in the model somehow to train models to be fair. Okay, so we will still be in the framework of machine learning, but we want to add something to get fair models. This is the second part of the work we've been doing. So now you basically, if I may, two definitions of fairness. One of them is called group fairness. So we just look at demographic, we just look at the overall distributions. Okay, so demographic parity is the most classical one, which says the prediction should be independent of the sensitive attribute. which is the most obvious one you might think of, which is very popular like in HR. When you want to be fair, when you want some recruitment, you want the probability to get an interview to be independent of your gender, to be independent of your race or whatever. Okay, so it's a very classical definition you can find in a lot of countries in legal, with a legal perspective. It's a classical one. So basically, if you've got two groups of discriminated people, you want the average value to be the same, which is more or less the definition you can find in most of the computer science paper. But it's maybe not sufficient because, as I told you, we just focus on the average value. It's a very weak definition of demographic parity. Maybe we want more because, as I told you, I don't care about the prediction of classes. I don't care about who's going to go to the doctors, who's going to claim a loss or whatever. I care about the scores because scores will be premium. So maybe we want more. Maybe it should be based on distributions. Okay? So maybe we want to get distributions in the two groups to be the same. It should make sense. So that's more or less what we ask, and interestingly, so what we need is basically a distance between distributions, conditional distributions. And then we have two other definitions. Equalized odds, so it's basically the same idea, conditional on Y, which is quite natural if you focus on binary outcomes. If it's continuous, it might be a bit more complicated, but we can still do some sort of local averaging, okay? So you're going to look at basically the false positive rate and this kind of stuff, okay? And then there's the last one, which is the same kind of property, except that you flip the Y and the Y hat. So the absolute value and the conditional one. And this is a different definition, very close actually to the question of calibration. So we look at Y conditional on the score and conditional on the sensitive attribute. Okay, so those properties, there are a lot of papers talking about impossibility theorem, so it's not possible to get everything at the same time. So there will be some choices. Okay, so we need regulators, we need people in charge of legal issues to know about those properties, try to understand which one is the most important. So I think we need people with maybe some more background on social sciences, philosophical perspective. So Michele has been working on those different topics. We need people with a different background to tell us what are the implications, social implications of different definitions. Okay, because, well, you don't talk to lawyers with these kind of formulas. I mean, basically they don't get it. I mean, if I try to be polite. So we've been focusing on those questions. So group fairness is one way to look at the problem. There's also a different one, which is so we can focus on looking at distances, maybe looking at mitigation, but we might also look at individual fairness. So individual fairness is not looking at the overall distribution like from a regulator's perspective. It's really about focusing on the individuals because, and it's the same in interpretability. You get the interpretability of a model from the regulator's perspective. They just want a broad idea, some sort of model agnostic perspective on what's going on. And then you got the explainability for people. Like, why was I rejected for my credit application? So basically, it's usually people who got a zero, predicted a zero, who want explanation. I mean, well, you have been students. So basically, if you got a grade which is higher than what you expected, you don't ask why was it so high. So you usually complain when you don't get it, right? So we want to understand what's going on, and it's related to the idea of creating a counterfactual. So was I discriminated because I'm old, because I'm a woman, because I'm white, because I'm black, or whatever? So we need to understand something which is very close to what people are doing when they talk about causal inference, which is about knowing what the outcome would have been if we change the treatment. Okay, so this is a definition you can find in different papers. One of them is this question of counterfactual fairness. So again, a lot of people in the room are working on this idea of creating counterfactuals on causal inference. So it's really about this question: had the protected attribute, such as the race or the gender, had been different, would the outcome been different? Okay? Everything remained the same. And one of the trick is this problem of everything being the same. We might wonder if it makes sense, actually. So to be honest, it was with a discussion with Jean-Michel Loubès, who's going to talk later on, who raised this point a few years ago, which is, does it make sense? I mean, if I try to create a counterfactual of myself, I'm an average guy, let's say 180 centimeter. If I had been a woman, can we still assume that I would be a woman with 180 centimeters? Maybe not, okay? And the idea is maybe we should not think in terms of covariates as numerical value per se, but maybe it's more the relative position. Okay, if I'm an average guy in terms of height, maybe I will be an average woman in terms of height. So it makes more sense to look at relative position within each group, right? We've been working also on this question in the context, so it's not exactly health insurance, but more or less. The fact that in the US, you can find a lot of information about women delivering babies, and we were wondering if black mothers are more likely to get surgery or not when they deliver a baby. And there is a problem, there is a difference. But maybe the difference is not coming from the fact they're black. Maybe it's coming from something else. So I'm going to show you some graph related to classical graphs we have in optimal transport, which is the fact that we have a distribution of the variable of interest, the height or the weight of the baby, in the two groups. So if I got a man with 180 centimeters, then the counterfactual as a woman will be a woman of 165 centimeters, because we are going to look at the same relative position. So basically, this is the median, somehow. And what you can see in the context of weight of babies, actually what you can observe is black mothers have smaller babies than white mothers. So because of the difference we have in the shape of the babies, maybe if they don't get surgery, it's not because they're black. Maybe it's just because usually they have smaller babies. Okay, so some discrimination can be seen as legitimate and non-legitimate somehow. So it could make sense to say that some black mothers feel discriminated because they didn't get surgery, but maybe it's just because they got smaller babies. And this can be seen as a non-segregated or non-racist perspective about insurance. Okay, so this is something we've been working on quite intensively. Actually, there are a lot of people have been working on that. There was a very nice paper by Luca De Lara and Jean-Michel Loubès on this question of creating counterfactuals, actually using optimal transport. We've been doing almost the same kind of thing on probabilistic graphical models. So how do we distort things when we have a causal graph? Another thing about discrimination is, usually discrimination is about the fact that we have a variable which is at the beginning of the graph, right? A causal graph means that you have a variable that is going to influence something. What we say about discrimination is we have discrimination when we cannot control something. Okay, color of the skin is something you cannot choose. It's not something that you decide. So it's seen as discriminatory. Okay, so in many cases, actually, the sensitive attribute is at the beginning of the graph. So it's possible to see what the change on this treatment will impact the different x's, and then try to take that into account into modeling the outcome. Okay, so it's also something we've been doing. And finally, because at some point I will have to stop, I can talk about mitigation. So there's a very nice technique that we've been using recently about mitigation, but actually it's coming from, again, people in the room. So there are a lot of papers about looking at discrimination in insurance. There are differences, especially with respect to gender. Okay, think about whatever you might think of in insurance, and there are usually differences with respect to gender. If the law and regulation says you need to mitigate, are there any techniques that can be used to mitigate? So it's possible to use different techniques, right, to mitigate discrimination. Isabelle has been working on in-processing approaches. So basically, you train your model minimizing a loss, and then you plug in a constraint about fairness. So it's a natural way to look at in-processing techniques. Okay, so it's just adding a penalty, not related to complexity of models like in Lasso or those kind of models, but it's really about having a constraint about fairness. Okay, so in that case, you will be able to reach fairness in this in-processing approach. But it's also possible to do it ex post. So it's possible to train your model as usual, and then at the end to say, okay, I got a difference. Obviously, I got a difference. This is a score for men, this is a score for women. There is a difference in the distributions of scores. Is it possible to mitigate that? Okay, so we can see that on the graph. So we have this transport problem. It's not on the diagonal. There is a difference. So if I got someone with 60% score predicted in group A, then again, it should be the median. So the counterfactual version of that person, the equivalent of that person in the other group, being in the median would be more 40%. So there is a difference because the score of 60% is not the same as 40%. Okay, but it's possible to mitigate because what mitigation would be about? It's to say, okay, I got a distribution of scores. I want to get a distribution which should not be different for men and women. So we want to be somewhere in the middle. Okay, why somewhere in the middle? Also because of this balance property I was talking about before. We still want to get, on average, the same prediction as before. So it's also about shrinking somewhere in the middle. So we want to get in the middle. And how can we get in the middle? Well, we have a very nice tool, which is Wasserstein Bayes Center. So Evgeny has been working on that. Jean-Michel also. So it's possible to get the distribution in the middle. And actually, there are very nice and intuitive perspective on this biocenter. So the definition, and actually Jean-Michel wrote a theoretical paper on those biocenters. We don't need to go too deep into the details to understand what's going on. And it's very intuitive because optimal transport is about mapping people together in two groups. Okay, so when you have two distributions, two samples, we're going to say, okay, the lowest risk in group A should be matched with the lowest risk in group B. Okay, so if you want the biocenter, you just have to be somewhere in between those two. So actually, when you look at the discrete version of Weierstrass biocenter, it's just the biocenters on the sample points. And you can compute it when you look at the average. So you can compute the average distribution, which will be the biocenter of the two. And that's nice because and we have also something else. I'm going to be a bit fast because I don't want to spend too much time on optimal transport, but optimal transport is about mapping one distribution to the other one. How should we transport? And actually, in the case of univariate distribution, which is usually what we have in insurance, when we focus on SCOR, it's possible to get the mapping to go from those discriminatory distribution to the one in the middle that should be fair. So it's possible to see that we're going to distort. So a man should be, so actually if you focus on men and women in insurance, motor insurance, so women are less risky than men. So we are going to overcharge a bit women just by saying, okay, I'm going to take an average of what you would be predicted as a woman and what you would have been predicted as a man if you had the same quantile position in the distribution. So, okay, so it's just looking at averages, and it's possible to look at different, it's possible to have guarantees that it's possible to mitigate. And there are also a lot of interesting properties in terms of optimality. Okay, so it's also possible to prove that actually this technique is going to be the one that gives you properties in terms of accuracy. Okay, so we can get at the same time accuracy, which is something that somehow people are still interested in, and fairness. So it's possible to do something with this kind of approach. Okay, so we've been working a lot recently on those Weierstrass biocenter, which is also, I think, a nice tool to get guarantees to be able to mitigate. Okay, maybe we can just conclude with one slide, which is about having mitigation. I don't say that we need to mitigate, but maybe it might be coming. So you might have this constraint coming from your company, coming from regulation, coming because, well, you have ethics. Okay, so should we do it? And when we look at mitigation, it's usually a difficult problem in terms of philosophy. Actually, it's not a math problem. It's really about what we want to get. So I just mentioned two statements from Supreme Court judges in the US. One of them was from the 70s, saying that basically, if you want to treat people equally, you must treat them differently. What basically it means is you need to do a affirmative action. Okay, so if you don't want to have any disparate impact, you must do disparate treatment. What it means is basically if men and women are different, but you want to get equality, you want to force to get equality, then you must do affirmative action. It's necessary to distort everything to get this. And then you have the counterpoint, which was actually later on, again in the US, saying that if you don't want to discriminate, then don't discriminate, which is more or less a statement that you can find in the ADA statement of Donald Trump, saying that you don't want to do any affirmative action, treat people as they are, don't make any discrimination. So it's a very opposite perspective on this question of discrimination, but it also kind of makes sense, saying that if you don't want to make discrimination, don't make discrimination. There are also some textbooks about that, about the fact that is affirmative action discriminatory and stuff like that. So this one is more or less the same, except that you take the opposite. So if you don't want to get disparate treatment, then obviously you're going to get disparate impact just because that's what you got in the data. Okay, so unless we've been able to change what's going on in our data set, distort them or do something, well, we're just going to replicate what we got in the data. Okay, so I'm going to stop here. I just want to again thank the SCOR Foundation. I mean, this event is related to the fact that we got this funding on focusing on discussion on fairness, discrimination, counterfactuals, interpretability. We have a nice team of colleagues, students, and postdocs that are actually funded by the foundation. So I'm very glad that we got that. We just wanted to, so I just wanted here to explain what we've been doing on those questions with the team in Montreal. We still want to go on those problems. We'll still be working for the next at least year and a half on those questions. If some of you are interested, you can just follow us. We have a newsletter where we explain what we do. So I will be very interested to chat, and I will leave the floor for other speakers, clearly more interesting than me, that will give you other perspectives on the question of fairness. Thank you.
Thank you, everyone. So we still have 10 minutes for questions, in case in the audience you have any. Don't be shy. Yes.
So there was an idea that you mentioned several times that has been discussed by philosophers and economists to death in the, I think it was the early 90s. So when, within this paradigm of justice that tries to equalize what people get based on the efforts and to discount the effects of luck on their outcomes. The economist John Roemer basically proposed the solution you just proposed. He was saying, so if you take, let's say, effort, so study, how much you study, how much you smoke, you should look at the distribution of effort in the luck category, so let's say like man or black, and then map the effort, the morally relevant effort to be the equivalent place in the distribution, the same percentile in the distribution. So someone in the fourth quintile of effort for men should be treated as someone the quintile effort for women. And this applies to all luck categories. So we look in distribution within the luck categories of this effort thing. And there was a reply to that, one of the many replies by Susan Harley, who wrote a book called Luck, Justice and Knowledge, where you can find this reply, which equally applies as an objection to your approach, to say that basically we can't really assume that. Like, how can you know if someone, say, from a disadvantaged background, who's been putting lots of effort in the study, would have made the same efforts as this person being rich? Maybe she would have taken, just a different path, saying, okay, I don't need to make so much effort to get a good job and so on. I can realize myself by doing poetry. I don't know. So it's a challenge, I think, there.
Yeah, thank you, Michele. So something I didn't mention actually is the fact that this topic on fairness and discrimination has been there for years. And economists have been working on those questions with a slightly different perspective, mainly focusing on salaries. So what it would be the legitimate salary if you got different backgrounds, if you got different features. And I think our focus is more on the fact that those topics have been reframed, I would say, not more than rediscovered by people in computer science, but at least I think they put a mathematical framework that could help to get a better understanding of what's going on. But what we miss, I think, nowadays is those kind of discussion with people coming from human sciences, showing us what we've been learning from economics and philosophy about those questions, to raise some points saying, okay, math is nice, but maybe we need more to look at social applications and stuff like that. So I think this discussion between communities is something extremely important, and I'm glad that you raised the point that actually economists have been working on these issues. Some people were proposing answers, and there were already some critics, so maybe we should try to bridge the different approaches, because it's clearly a difficult problem, yes.
Thank you very much.
Yes, thank you very much. Just one question, Arthur, because at the beginning of your speech you were saying that the law of one price was not prevailing in insurance, which is something which surprised me, because I don't see where is the difference between insurance and, for example, the industry, because of course we are using different actuarial tools. Most of these actuarial tools are, and the data associated are proprietary and therefore private, but at the same time, there is a market with consumer making his choice. And of course, if you have, for example, if you benefit from different diversification benefits, of course, it influences your costs. But at the end of the game, the prices I will, as a consumer, choose the prices which is the most appropriate. And the consequence is my margin will be rather different, and therefore there will be a pressure, at least in the sense, in the direction of a one price law, which is not the fact that there is never a one price law, even in industry, but there is a trend towards the one price law.
Possibly, but I guess no. So my point, so the law of one price says, so it's really in mathematical finance when you have a complete market saying that if you got two portfolios with the same values at all the states of the world, they must have the same prices. And I think it's not necessarily the case in insurance. You can still have different, and also insurance company, I mean, they still have some beliefs about a lot of things. So it's, I'm quite sure you can still have a market living with two insurance companies with different perspective, or maybe they don't want to go too deep into segmentation. But it is.
My risk is not the risk.
Exactly, but
And therefore, comparison is not possible because we have never seen the risk as such.
Exactly.
As an abstract matter of consumption.
But still you can see it on markets where you can do securitization. The price you get on financial market is not the same the one on insurance markets. So obviously there should be some difference. Yeah. So for a lot of reasons, there might be legitimate differences on prices. So I still believe that it's still possible to have a running market with a non-unique price, which, I mean, I hope we have that because I think this is where insurance is challenging. So this is why I really love those kind of problems. Yeah.
We have time for one last question.
Thank you, Arthur. Just a question about the sense of fairness in some case, because I would take the example of sex. In insurance, we know that men, as you show, the frequency of claims is greater for men than for women. So if we mitigate this effect, is it fair in some sense? In which sense is it fair? Because is it do we want to mitigate this bias for legal reason?
Okay. I can mention a little something that I did not have time to put in the slides. But is it fair to mitigate when you have a difference? And,
yes.
A connected question is: could this difference come from a variable you didn't observe? Which is clearly the case in motor insurance. So basically, we have a difference between men and women because most of the time men drive more than women. So because of the exposure, we have a difference, but most of the pricing models don't have this one. But if it was possible to have it, actually, you don't need the gender. So the fact that we observe something might be because of missing information, actually. So we are going to make a distortion to mitigate, while possibly if we had access to some information. So I say we don't have access to that just because of this prior problem with insurance, which is we sell the product before observing anything. So it's still possible to get a prediction of how many miles or kilometers you're going to drive, but it's not exactly what people might be doing. So I think there's also this problem of non-observing something that could lead to potential differences. Yeah, so I think maybe it's not that simple to say that we should mitigate, because actually it might be coming from something else. And one example is basically Simpson's paradox. Simpson's paradox, if you just look at the very basic idea, so Simpson's paradox in the first paper on Berkeley's admission, when you look at the admission rates between men and women at Berkeley, women were less accepted than men, so you're going to say we need to do mitigation, we need to help women to get accepted, but when you were looking at different programs, it was just the opposite. So it says, well, if you got the admission in each program, actually you should do the opposite. So it's not that obvious that if you should do this, you should do mitigation, especially if you're not sure that you collect all the information you need. But in many applications, either you cannot because it's not legal to get some information, or basically you cannot because it's this problem of temporality in insurance, which is you don't observe something. But if you could predict it, maybe it could help. I'm not sure.
Okay, thank you.
Thank you very much. So I think that it sets the floor for the day. Many questions, many open questions. Hopefully, with all the presentation, we'll know more, or at least we'll learn something about some of those challenges. So conscious of the time, so after having setting the floor and explaining, thank you Arthur for all the explanations. So we have some time for a short break to still continue the debates on some of the open questions. So let's take 20 minutes short break. So to continue the day with then two great presentations that are coming. So let's start to come in 20 minutes.
Quand on parle de discrimination, qu'on va considérer la loi de distribution donc n'importe quoi. Je me demande dans quelle mesure ça ne génère pas une inégalité sociale. In fine. Je le fais à la grosse. Mais derrière, je me demande, parce que je dis ça par rapport au fait que si par exemple on prend une petite fille et on la compare depuis 50 ans, si on la compare il y a 50 ans, statut, voilà. Question, juste. Dans nos pays. Alors c'est sûr que c'est pas le cas en Chine. C'est sûr que c'est pas le cas en Papouasie, mais en France, aujourd'hui, je ne sais pas. Je pose la question.
Après, ta question, je l'entends dans un sens dynamique du jeu, quoi.
Oui,
Et
absolument.
ça, c'est le truc que typiquement personne ne regarde, mais effectivement, on se doute bien que, ok, on a vu qu'il y a une différence, on fait quelque chose. L'étape naturelle, c'est de dire, bon, bah, il se passe quoi et comment les gens vont répondre, enfin, c'est quoi la dynamique, quoi. On voulait vraiment travailler là-dessus, mais c'est un sujet, je trouve, assez compliqué. Alors, ce qu'on a déjà vu, c'est si jamais il y en a qui jouent le jeu et pas l'autre, hein, déjà, c'est très compliqué. Même si tout le monde joue le jeu, voilà, moi, j'ai fait un tout petit peu de système dynamique de l'enfer sans parler de bonne intention, quoi. Et donc on a l'impression qu'on pourrait faire des choses qui semblent aller dans le bon sens, mais qui au final créent des effets inattendus. Et en fait, on a plein en assurance. On avait travaillé avec un assureur au Canada, alors c'est pas TD. Et eux, en fait, dans Newfoundland, le nouveau territoire, en fait, il y avait une loi qui disait on n'a pas le droit de discriminer contre les personnes âgées. Ça me paraît pertinent. Donc ils ont arrêté d'utiliser cette variable en tarif. Sauf qu'il y a un petit problème technique que personne n'avait vu venir, c'est qu'au Canada, le Canada est une terre d'immigration, il y a beaucoup d'immigrés, et quand tu immigres et que tu demandes un permis de conduire, on te remet ton compteur à zéro. Et donc en fait, la discrimination, elle s'est faite envers les immigrés. Et en fait, il y a toujours un trade-off qui est, si jamais tu veux être fair sur un critère, peut-être que tu vas être unfair sur un autre. Et donc en fait, le jeu, il va être compliqué parce que tu t'en rends compte. Tu dis, attendez, on rétro-pédale, on va changer. Et en fait, c'est vraiment des questions complexes parce que... Mais voilà, c'est vraiment la première phase, c'est awareness, il faut être au courant que c'est compliqué. On va pas apporter de solution.
Mais enfin, je pense qu'il y a...
Oui,
Parce que le problème qu'on a dans la logique, en tout cas en France, dans la logique sociale et professionnelle, la finance, à un moment donné, va être la réalité de la décision. Mentalité. Et puis nous, on commence à venir à un âge où on prendra probablement et on se place en relatif par rapport à cette classe un peu derrière les conséquences sociales dans les décisionnaires qui vont parce qu'on est quand même on est quand même dans un pays où à un moment donné, on n'est pas toujours très rationnel, mais à un moment donné, si on prend la rationalité, elle vient.
Oui, sauf que la rationalité, elle est compliquée. C'est aussi notre problème. C'est-à-dire qu'il y a des différences qui sont explicables. Ah oui, mais c'est ça, non, mais je suis d'accord. C'est pour ça que je suis très content qu'il y ait des gens du contrôle, des gens de... C'est pour ça qu'on a besoin d'avoir des gens qui prennent des décisions, au moins pour être conscients et qui réfléchissent. Parce que le point de départ, c'est compliqué. Et on peut en parler avec les gens. Ah, mais clairement, ça moi, je milite pour ça, que les acteurs depuis très longtemps.
Mais c'est bien d'en discuter.
Ah oui, oui.
Toi, tu as...
Je suis toujours au Canada.
D'accord.
Après, je tape mon nom et je ne me cache pas trop. peu à la formule de blague où tu dis, bah, d'abord je pense pour tout simple, puis mieux conditionner les simples. Et en fait, c'est pas, voilà,